Everyone. So next we'll do this problem. Okay, here the question is, for the resistive T network shown below, find V2 by V1, V2 by I1, I2 by V1 and I2 by I1. Okay, so it is a circuit, this circuit right here, and here you can see this is not your ordinary ladder circuit, right? A ladder circuit is a circuit which is having all parallel elements, right? Across each node there is a parallel elements. That's why you call it as a ladder circuit. Here this is not a ladder circuit. Here this is actually a non-ladder circuit, or simply you can say this is an ordinary circuit, right? So for these kind of circuit you need to apply, it's always easier to apply Kirchhoff's voltage law. Okay, if it is a ladder circuit, you need to apply Kirchhoff's current law, so that you can find the answer easily. In the same way, for these kinds of circuits, that's non-ladder circuit, we use Kirchhoff's voltage law. That is the best thing to apply, Kirchhoff's voltage law. Okay, and also this circuit is called as a T network because this is the shape of a T. That's why it's called as a T network. And since there is no inductors or capacitors or anything like that, that's why this is called as a resistive T network. Okay, so now you need to look for V1, I1 and V2 and I2. So you need to look for all of those four parameters if you want to find your answer. So what is V1? V1 is shown over here, I1 is shown over here, V2 is over here, which means V2 is the voltage across this resistor, and I2 is the current. You see, you need to learn to mark all these four parameters even if it is not been shown in the question. For example, if they have only shown you V1 and V2, but they have not shown you I1 and I2. So in that case, how to draw I1 and I2? You need to understand that I1 is in this network, for network functions, I1 is drawn in such a way that it is coming from port 1, or it is coming from V1 always into the circuit. The same way I2 also. I2 always flows into the circuit. Okay, that is how you need to find. So let's start with. So here in this case, if you look over here, you can see what is this. What is V2? V2 is the voltage across this resistor. V1 is the voltage source. V2 is the voltage across this resistor, this 1 ohm resistor. What is the current through the 1 ohm resistor? That current is called as I2, right? So in that case, according to Ohm's law, we can write the equation, that is V is equal to IR. So what is V over here? V is of course V2, okay? But what about I? What is the value of I over here? We know that the current through this 1 ohm resistor is I2, okay? So what is the value of I over here? You can see over here that this is the higher potential. If this is the higher potential, then this point is the higher potential. Likewise, this point is the lower potential. And we already know that current always flows from a higher potential to a lower potential. So which means the current of V2 is supposed to flow from top to bottom. But if you look at the direction of I2 is going into the circuit. So if according to the circuit, I2 is flowing from bottom to top, so it should be minus I2. So that means the current that is flowing through 1 ohm resistor is minus I2 into what is the value of the resistor? 1 ohm. This is the equation, that is, so you already got one equation, right? V2 is equal to minus I2. Or in other words, V2 by I2 is equal to minus 1. Did they ask for V2 by I2? No, they did not ask for V2 by. If they had asked, then this answer would have been very easy, right? Immediately I have already found out that V2 by I2 is equal to minus 1. They have not answered the question. So now let's find the remaining parameters. So here, nothing else to do. There is nothing much here. You have already did these kinds of problems so many times. There's nothing but applying your normal Kirchhoff's voltage law and finding the value or finding the equation for I1 and I2 or whatever. Okay. So here, but look, the difference between this problem and your previous Kirchhoff's voltage law problem is the direction of your mesh current. Always you used to mark your mesh current in clockwise direction, like I1 over here. You see, I1 is marked in clockwise direction. I2 is also marked in clockwise direction. If this is mesh 3, then I3 is also marked in the clockwise direction, right? Here also we can mark mesh 3 as like that, clockwise direction, both of them. But I cannot mark I2 over here because I2 has already been marked. You see, I2 has already been marked, and look at the direction of I2. It is going from right to left, which means you need to follow this direction, which means this direction. This is how it should be done. in this chapter, in this circuit, when you are going to apply mesh analysis, this is how you need to mark your currents in the direction of the, you need to mark your direction of the current in the same way how it is marked in the, or how it is given in the circuit itself. So see over here, the direction is like this. So this is how you should assume your I2. This is how you should assume your I1. Okay, that's the only difference between this problem and your previous Kirchhoff's voltage law problems. Because in your previous Kirchhoff voltage law problems, in your previous mesh analysis problems, you don't know the direction of I1, I2 or I3. So what you're going to do is you assume all of them in the clockwise direction. But here you know the direction of I2. So that is why you need to change your direction of your usual way of marking your mesh current. Okay, so that is one thing you need to remember. Now, if you don't like this method, okay, I'm just telling you, if you don't like this method, then what you can do is you can mark your own mesh current, but you need to give another name to it. For example, you can give this name IA, this is IB, and this is IC. In that case, all three currents you can mark it in the clockwise direction. So in that case, the equation will become I1 is equal to IA, I3 is IC itself, and here IB is equal to minus I2. That's all. If you don't like this method, you can mark like this. You can use your normal mesh analysis problem, but you need to change the name of your mesh current. Don't use I1, I2, I3 because I1, I2 has already been used over here in the as name of your input port and your output port currents. Okay. So now let's apply your normal mesh analysis. So first I will apply mesh over here, applying KVL to mesh 1. Okay, so we get, by now all of you should be able to do this very fast. Okay, here it is, I1 is touching these two elements, so it's 1 plus 1 is 2. Then we have minus I2 into, and this is I2 is touching only this element, right? But if you look over here, it is not I2, it is plus I2. Why it is plus I2 is because this current across this resistor, both I1 and I2 are flowing in the same direction. Both of them are flowing from top to bottom. Both of them are flowing from top to bottom. That is why it is plus I2. Okay. If like I said, if it had been in the clockwise direction, this would have been minus I2. Okay. But this time, you have changed the direction. Here, look over here. In all other cases, the direction of the mesh current is always assumed to be the clockwise. But this time, in this circuit, this current is flowing in the anti-clockwise. Okay. That is why. And if you're talking about I3 is flowing the opposite, so it's minus I3 into 1 is equal to V1, or in other words, the equation is 2I1 plus I2 minus I3 is equal to V1. Okay, so this is here equation 1. You can use this as equation 1. Now next is applying KVL to mesh 2. So in that case, this is mesh 2, and you will see that both I1 and I2 are flowing the same direction. So it is plus I1 into 1 itself, plus I2 into 1. No, I2 is 1 plus 1 2, 2 plus 1 3. Then you have minus what about I3? I2 and I3 are also flowing the same direction, right? If you look at this resistor, both I3 and I2 are flowing from right to left. Both of them are flowing from right to left. Both of them are flowing the same direction. So it's also plus I3 also. Okay, plus I3 into 1 is equal to, there is no voltage source, so it is equal to 0. Or I can say that the equation is I1 plus 3I2 plus I3 is equal to 0. Okay, so that is the equation for mesh 2. Next is applying KVL to mesh 3. Alright, mesh 3 we get over here as, so here if you look at mesh 3, I1 is flowing in the opposite direction of I3, so it is minus I1, and the I1 is touching only this resistor, this is 1 ohm, And what about I2? I2 and I3 are flowing the same direction, right? We know that. So therefore, it is plus I2 into 1 plus I3 into, and what about I3? 1 plus 1, 2, 2 plus 1, 4. 4 is equal to 0. There you have it. So this is equation 2, this is equation 3, expressing these three equations in matrix form, okay? Expressing equations 1, 2 and 3 in matrix form. So we get is, what we get over here is, let me see, here it is 2 plus 1 minus 1, 2 1 minus 1. What about the next one? 1 3 1, 1 3 1. Next is minus 1 1 4, minus 1 1 4, and here it is I1 I2 I3 is equal to, and over here it is V1 0 0, V1 0 0. Okay, so we got this one. Now we can write the equation for I1. What is the equation for I1? I1 is equal to determinant of V1 0 0 1 3 1 minus 1 1 4 by the determinant of this coefficient matrix, which is 2 1 minus 1 1 3 1 minus 1 1 4. Okay, and we will get here it is V1 into 3 to 4 is 12, 12 minus 1. Okay, here it is 12 minus 1 by, and over here it is 2 into, again it is 12 minus 1 minus 1 into 4 plus 1, 4 plus 1 plus, no sorry, it's again minus 1 into, it is 1 1 plus 3, 1 plus 3. So this is equal to V1 into 11 by, and this is 12 minus 1 is 11. Let's do this calculation over here. It's much more simpler. It is, we have here as 2 into 11, 12 minus 1 is 11, minus 4 plus 1 is 5, minus 3 plus 1 is 4, and you get 13. So this is equal to 13. Okay, so this is one answer you got over here. It's 13, right? So which means I got I1 is equal to V1 into 11 by 30, or in other words I can say that I1 by V1 is equal to 11 by 30. Okay, I1 by V1 is equal to 11 by 30. Did they ask for I1 by V1? No, they did not ask for I1 by V1 also. Oh, they won't ask for the easy ones. Never. Next is I2. I2 is 2 1 minus 1, and here you have V1 0 0, then here you have minus 1 1 4 by, and here it is 2 1 minus 1 1 3 1 minus 1 1 4. Okay, so here it is minus V1 into, this is 4 plus 1 by 13, and this is nothing but minus V1 into 5 by 13, or in other words I2 by V1 is equal to minus 5 by 13. And if you are interested in unit, here unit is mho, opposite of ohms. Here also, okay, it is mho, conductance, right? That's why it's a unit of conductance. So this is the equation. Did they ask for I2 by V1? Oh yes, they asked for I2 by V1. So I got one answer. Okay, I found I2 by V1 Okay, now next is you don't need to find the equation for I3 because I3 is not one of the currents, right? The port currents. I3 is one of the mesh currents, so that's not use. There's no use of finding I3. So now you need to find this. You need to find this V2 by V1. Let me write it over here. You need to find V2 by V1. You need to find V2 by I1, V2 by I1, and you need to find I2 by V1, you need to find I2 by V1, and you need to find I2 by I1. I2 by I1, okay? And out of these four, I already found I2 by V1, okay? So no need to find that. Now, next is I need to find V2 by V1. So one more equation also I need. We found one more equation. We know that V2 is equal to minus I2. We know that, right? V2 is equal to minus I2. V2 is equal to minus I2. So in that case, I can put minus V2 over here. So what will I get? I'll get minus V2 by V1 is equal to minus 5 by 13. Therefore, V2 by V1 is equal to 5 by 13. So I found V2 by V1. I found this, okay? I found this. Next, I need to find is V2 by I1. Alright, I can find V2 by I1, right? V2 by I1 is, we know what is I1, right? What is I1? I1 is, this is I1, that is 11 by 13 V1. I1 is, let me write that, I1 is equal to 11 by 13 V1. Okay, and what about V2? What is V2? There's no equation for V2, but V2 is equal to minus I2, and I2 is already given by this one. Okay, so we know that V2 is equal to, right? Or in other words, we can say that V2 is equal to, yes, of course, V2 is equal to 5 by 13 V1, right? So over here, see, V2 is equal to 5 by 13 V1. So therefore, I can now find what you want to find, V2 by I1. So therefore, V2 by I1 is equal to, V2 is 5 by 13 V1 by 11 by 13 V1, okay? And this V1 will get cancelled, and this denominator 30 and denominator 30 will get cancelled, and you will get 5 by 11. So therefore V2 by I1 is equal to 5 by 11. V2 by I1 is equal to 5 by 11. We found that also. Okay, that also I found. Next is I2 by I1. Oh, that's very easy, right? I2 by I1 is over here. I just take this one and divide by this one. So therefore I2 by I1 is, I2 by I1 is equal to, what is I2? I2 is minus 5 by 13 minus 5 by 13 by, what is I1? I1 is 11 by 13 V1. 11 by 13 V1. Okay. So therefore again, so you will get us minus 5 by 11. So therefore the answer is, the answer is V2 by V1. First I'll write V2 by V1. V2 by V1 is equal to how much? 5 by 13. No unit because both of them are in volt. So volt denominator and volt numerator will cancel each other. Okay. So this is first answer. Then the other one they ask us to find is V2 by I1. V2 by I1 is over here. That's 5 by 11. V2 by I1 is equal to 5 by 11. And then we found out that V2 by I1 is 5 by 11. Then we found out that I2 by I1 is minus 5 by 11. And I2 by I1. I2 by I1 is 5 by 11. Then what else do we find? I2 by V1 I have written, right? I2 by V1. No, okay. So and I2 by V1 is equal to minus 5 by 13. Okay. So these are your answers.